All right, for this next part of notes, we're not going to go through all of this. We're going to kind of hit some high points. Um, First part asks, how do you find an object's average velocity? Well, velocity, remember, if you've taken physics or anything else, any science class, velocity is the distance divided by time. So the average velocity is going to be the change in distance divided by the change in time. Well, change in distance over change in time, that's kind of like what we talked about with slope of the secant line yesterday. Right? Slope is just a change in y over change in x. This average velocity is like that slope of the secant line. And you can kind of disregard this stuff. We're just going to write a few other things in here. Um, the big thing to take out of this is the average rate of change is just that difference quotient that we looked at yesterday. F of a plus h minus f of a all over h. Or the alternate way, or way that we'll probably start to see it a little bit more, is just f of x plus h minus f of x all over h. Right? The a is when we're looking at a specific value, like at a specific point. F of x plus h minus f of x. When we're using x, we're doing it in more general terms, which we'll start to use a little bit more. But that's the average rate of change. We can also use this, one thing that we'll use it a lot for is the average velocity. All right, average velocity we can find the same way. This function here is going to be our distance, right? Change in distance or change in position. So that's something we'll use for average rate of change a lot. And this is a recurring topic that we'll see throughout the year, average rate of change. So this is definitely something you want to put on your chapter review sheet, which I haven't given you yet. So the average gives you an estimate, an average over time. And what this stuff here was talking about is that if you're looking at an average over a long period of time, that's not giving you a very good picture of the specific velocity at any given time, because it can change a lot within a large time interval. So average velocity is not always the best thing, or average rate of change is not always the best thing to look at. If you want to figure out the velocity or rate of change at a specific point, we're talking about instantaneous velocity or instantaneous rate of change. So instantaneous rate of change tells us how something's changing at a specific time, at a very specific time, rather than over a large interval of time. That's what we talked about yesterday with the limit. Right? That's the tangent line. That gives us the rate of change at that instant. So the limit as h approaches 0 of f of, I'm just going to use x now, plus h minus f of x all over h. Right? Same thing holds true for instantaneous velocity, but the whole bigger picture, instantaneous rate of change, it could be any type of rate of change. It doesn't have to be velocity. All right, another big idea, big topic for calculus right here. All right, that tells us the instantaneous rate of change.